So we have chosen a magnetic compass in place of a tester, and it is connected again to a battery. You can see the long line positive, short line negative, and this is the wire, as you said, conducting wire is dipped in a beaker. But you can see the beaker is empty. Here we took lemon juice or vinegar and did the experiment. Here also, children, we will consider various other things in order to check its conductivity. With the help of lemon juice and vinegar, we understood that liquids are also conducting. Once we know something, liquids are conducting, we are curious to check with various other liquids. It is not like salt is the only liquid or vinegar is the, lemon juice is the only liquid or lemon juice is the only liquid or vinegar is the only liquid. You have the normal tap water, you have distilled water, you have oil, you have vegetable oil, so many liquids you can list for that sake, and you should be curious to check whether it will conduct or not. So sometimes few things or substances what we use for conductors, liquid conductors, maybe bad conductors or maybe a weak conductor of electricity is the word. It is not good but not bad as well. It is in between. It may be a weak conductor of electricity. Andre, it will allow only small amount of current to flow through it. So such substances, the current, it will conduct or not, can be checked with the help of this magnetic compass. The tester may not work for such small current. So magnetic compass we are replacing by the tester so that it can detect the presence of small current. Now we have left the ends of the wire free, and make sure when you are conducting the activity, these two wires which you are dipping inside the solution should not touch each other, children. If you are doing so, then the short circuit will take place. You should be careful. Now what we will do is, first we shall fill it with the normal tap water or the normal water what we drink. We shall put it. When you do so, then you should check whether here there is no bulb to glow, isn't it? Bulb didn't work, so flop, we left. What we are doing is, we are checking the magnetic compass when you are dipping the winds of the wires in the normal tap water. If there is deflection seen in the magnetic compass, then we say yes, it is conducting. Andre, there is current anta. If there is no deflection seen in the magnetic compass, no, it is not conducting anta. Children, when we take the normal tap water, we observe that there is deflection. The deflection will be seen in the magnetic compass. If there is deflection seen, then of course we can conclude that yes, the normal tap water is conducting. You might have heard your parents telling you not to touch any switchboard or switch or any device or with the wet hands. Yes, why do you think so? Because we know that the normal tap water, what we consider is a good conductor of electricity, isn't it? So, you should not touch any switch or switchboard or any appliance with wet hands. When it is working especially, don't touch the switchboard. Don't switch on the switch with the wet hands, because you feel the electric shock. Why do you get that electric shock? It is because the water is a good conductor of electricity. Hence, when we take this normal water, tap water in the beaker and dip the wire, there is the deflection seen in the magnetic compass, which shows that normal water is good conductor of electricity. Okay, before I tell one more point, let me consider the distilled water. I will now take out the normal water, wipe the beaker neatly, pour the distilled water. Again, I dip the ends of the wire here in the beaker containing distilled water. We observe that there is no deflection seen in the magnetic compass. If there is no deflection seen in the magnetic compass, then it means there is no current. No current under tap water was conducting, but the distilled water is not conducting the electricity. Why do you think both are water only, but normal tap water is conducting, whereas distilled water is not conducting? Why do you think, children? The answer is very simple. The normal tap water what we use, it consists of, the drinking water what we use, it consists of various dissolved ions in it. Dissolved ions, IONS, ions in it. Or be simple, it consists of salt in it. Nowadays we use RO, UV, so many water purifiers at home, isn't it, children? To make hard water soft. When we are doing so, the required minerals or salts what are required for our body from the normal water are removed along with the bacteria or the thing what is present in the water. Hence they say that don't go to very higher end of water purifiers, because the normal water what we intake, children, it consists of some dissolved salts or ions, or it consists of minerals in it which are very much required for our body. But nowadays the such kind of water purifiers are available in the markets, which are not only removing the bacteria in the water but removing this required salts, ions and minerals from the water as well. You should not make use of such purifiers. Okay, the ions or the dissolved salts or ions what is present in the normal water are very much required for our body. But when we consider distilled water, you know what is distilled water, isn't it? You might have seen your parents putting it for the UPS. If you have at home, they pour the distilled water. So this distilled water, how do you prepare? You have studied in your lower class. The precipitation formed, if we condense, what we get is the purest form of water called the distilled water. So imagine we have taken the distilled water in this beaker now and dipping the wire, and I said you that we see no deflection in the magnetic compass, which means the distilled water is not conducting. So what we make it to conduct is, I will take a spoon of salt and mix it with the distilled water. What am I doing? I am just taking a teaspoon of salt and mixing it with the distilled water which is present in the beaker. When I mix it, immediately I see the deflection in the magnetic compass, which means the current is flowing. So what do we understand, children? The normal distilled water when we used to conduct, did not conduct electricity. But when we mixed it with the salt, see, immediately there was a deflection seen in the magnetic compass which shows the presence of current in it. Andre, distilled water is the purest form of water, we all know. It does not consist of any salts or dissolved ions which is present in the normal water, hence it is not conducting. But as soon as we mixed it with the salt, what happens? So we know salt is a good conductor of electricity. We know even our body 80% it consists of water. The human urine itself also consists of amount of salt in it. If you have watched the movie Three Idiots, children, there you can see one scene where Amir Khan, to avoid the ragging in the college, he goes inside himself, he locks, and you can see funny incident. They tell him that to come out of the room, and when he opposes, he does some small experiment, science experiment there, which helps you to understand what is conductivity and also understand. He used the concept that human urine consists of salt in it, and hence it is a good conductor of electricity. You can just watch that scene, or you might have already watched it. And so such things you should try to analyze what he did, why actually he did, how it helped to safeguard like that, and all you should understand that. So we know that salt water is a good conductor of electricity. So as soon as we mixed with distilled water, as soon as we mixed the salt with distilled water, it conducted. Like this, children, vegetable oil, honey, like this, any coconut oil, whatever liquid you want, you can take in the beaker. Just dip the wires. Every time you dip the wires, make sure you wipe, dry it, and then dip. If there is deflection, then current is there. If there is no deflection, no current under. So those liquids are not conducting. It is not like all the liquids will conduct electricity, children. Some may conduct, some may not conduct. In solids, you have no good conductors, bad conductors. Like in liquid also, you have good conductors and bad conductors. That experiment we have to check one by one whether it is conducting or not conducting. They have given a table in the textbook for the to check the conductivity of various materials. You can have a look and perform it as well. So thus we conclude that yes, liquid also conduct electricity. And to check whether it will conduct or not, we consider this circuit. A bulb, lemon juice or vinegar we checked, and the bulb glowed. But in some cases the bulb may not glow or the tester may not work. In such case, so we find it a solution to replace the bulb by LED and also tester by what? Magnetic compass. Because magnetic compass or LED bulbs helps in detecting the lower current or the very the small amount of current flowing through the circuit. So thus we conclude that liquid conduct electricity. So children, please watch the animation video and then listen to this explanation. You can understand it very easily. It is not something difficult concept. So you have this lesson for your upcoming FA3. Please watch the video, and I have already sent the notes as well. Please complete the notes and read the textbook as well. In the next session, we shall be discussing on what actually the chemical effect of electric current is. Till then, take care. Thank you, children.